back to another tutorial. Here we've got STAX Chapter 7, Problem 9. We have a lot of chemical names here, and we're supposed to write an equation. I'm also going to balance that equation. So we have aqueous hydrogen fluoride, okay, is used to etch glass and analyze minerals for their silicon content. Hydrogen fluoride will also react with sand, which is silicon dioxide, okay? So it says, write an equation for the reaction of solid silicon dioxide with hydrofluoric acid, that's right here, aqueous hydrogen fluoride, okay? To yield, that means reaction arrow, gaseous silicon tetrafluoride and liquid water. So obviously they're saying solid, liquid, gas, and aqueous and all this stuff because we need to keep track of the states when we write a balanced chemical equation. Okay? First, we want to write down the chemical formulas, okay? So aqueous hydrogen fluoride is indicated like this. Remember, AQ stands for aqueous. And that reacts with solid silicon dioxide, silicon dioxide. Silicon is Si. Okay. Dioxide means 2. Di means 2, so that's O2 here. Okay. And it's solid, so we want to write S here. Okay? And then that yields gaseous silicon tetrafluoride. So tetra means 4. And fluoride is capital F. Fl is a different element. That's fluorovium. I think that's element 109 if I remember. That's not the element fluoride. Okay, so fluoride is capital F. We also form liquid water. Oh wait, so that's gaseous. We want to write a G here. Okay. And then liquid water forms. You need to memorize the water is formula for water. Memorize the formula for water, methane, ammonia, those kind of common ones, okay? So here we go, we have a chemical formula here. A chemical formula is describing this reaction, but it may or may not be balanced, so let's take a look, okay? So we got 1 silicon, 2 oxygen. Oh, that's not balanced. Fluorine is not balanced. So again, this is trial and error. I'm just gonna pick from left to right. I'm gonna work on fluorine, because it kind of seems like an interesting element. I don't see a lot in chemistry. So we have 4 here, and we have just 1 here. So we're gonna put a 4 in front of this to fix the amount of fluorine, okay? Next, I'm just gonna pick on hydrogen. We have 4 hydrogens, and over here we have 2. So we need to double that by putting a 2 in front of the H2O. So now 2 times 2 is 4 hydrogens, and over here we have 4 hydrogens, okay? Next, we want to look at silicon. Silicon's balanced, that's good. Oxygen, we have 2 oxygens in this formula here. And over here on the right, we have 2 times water, which gives us 2 oxygens, okay? So at the end, always go back and check every single element. 4 H's, 4 H's, 4 fluorines, 4 fluorines, 1 silicon, 1, 2 oxygens, 2 oxygens, okay? So that's good. We'll box that guy up. So this is the final answer. As I emphasized in my other videos, always have the correct formula, always have the state for every chemical that you have in there, and then only change the coefficients or these white numbers here in a balanced chemical reaction. If you need a 1 for a coefficient to balance a chemical equation, we don't show it, okay? You don't put a 1 here in front of these chemical quantities because it's implied to be 1. In part B, we have the mineral fluorite, which is calcium fluoride. Okay, occurs extensively in Illinois. A lot of this is literary license, okay? We're just gonna box up the important words here. Solid calcium fluoride, okay, can also be prepared by the reaction of aqueous, okay? We're gonna keep that in mind, aqueous solutions of calcium chloride and sodium fluoride, yielding aqueous sodium chloride, So yielding means reaction arrow. Aqueous, okay, that's a state there. Sodium chloride as the other product, okay? Write complete and net ionic equations for this reaction, okay? Probably gonna need more space for this, so let me scoot this off to the side, and we'll use the next page for this. All right, so you might have to reread that a couple times, you know, pause the video, look at your textbook and so on, okay? And so let's go ahead and write this reaction here, okay? Solid calcium fluoride can be prepared, okay? So that's going to be the product. That's the other product they're talking about, okay? So we don't want to start with calcium fluoride because that's the thing we're preparing. Okay. What we want to do is the reaction of aqueous calcium chloride and sodium fluoride. So calcium chloride, which is going to be aqueous, right, is going to react with sodium fluoride. And that's going to form sodium chloride. All right, which is aqueous, it says right here in the problem. As well as the other product, okay? The other product is this thing they're talking about that occurs in Illinois, something called this mineral fluorite, okay, which is calcium fluoride. The calcium fluoride is solid. It says right here in the word problem, solid calcium fluoride, okay? So the word problem isn't really written A plus B goes to C plus D. It's all jumbled up in the word problem. So we're starting with calcium chloride aqueous, sodium fluoride aqueous. We're forming sodium chloride aqueous and solid calcium fluoride. Now let's try to figure out what the chemical formulas are for these things, okay? Now, all of these are ionic compounds. I know that because it's composed of a metal and a non-metal. Refer to the staircase in your periodic table. Calcium and sodium are on the left of the periodic table, so they're metals. Chlorine and fluorine are on the right of the periodic table, so they're nonmetals. Therefore, we use the ionic charges to try to figure out what the formulas are for these, okay? So calcium is in group 2, so we know it has a charge of +2. Chloride comes from chlorine, which is in group 7. It has a charge of -1, okay? So when you try to figure out the formula for calcium chloride, you can use the crisscrossing procedure to generate the subscripts needed to create a neutral formula unit, okay? So after we do this, we get calcium, okay? We just have one of those. We don't write the ones. And then we have chloride, right? There's going to be a 2 that comes down. So the formula for calcium chloride is CaCl2. We indicate its aqueous nature once again by abbreviating that with an AQ in some small parentheses down kind of near that chemical, okay, or right next to it if you want, all right? The next chemical mentioned in this reaction is sodium fluoride. Sodium is a group 1 element, so that means that its charge is going to be +1. Fluorine is right above chlorine in the periodic table. It's also a halogen, so its charge is going to be -1. Now, since they're equal in magnitude of the charges, we can just stick one sodium ion with one fluoride ion, and we're going to get the formula NaF, okay? So I'll write that right here. It's still aqueous, right, as it mentions here and also in the problem, so we want to write AQ. And then we have the yield, or produces, or the reaction arrow, okay? it says yielding on the problem. Now we need to write down the formulas for sodium chloride. Sodium chloride, remember, is just NaCl. It comes from the fact that chlorine is -1. It's in the halogens. Sodium is +1. It's in the alkali metals, group 1 of the periodic table. So we got just NaCl. It's aqueous. Okay. Next up, we have calcium fluoride. Remember again, calcium is +2, fluorine is -1. So when you do the crisscrossing there to figure out what the formula is, you start off with this situation here, and now you can just grab the 2 and make it come down. So it's going to be CaF2. Okay? The 2 comes down to the bottom right of the fluorine. Okay? And it's solid. Okay? We know it's solid because it says it here in the word problem, solid calcium fluoride. Okay? So all of that jumbly goop up here can be translated into a very succinct chemical, symbols and a reaction. Now, it's not balanced yet. It's not balanced. It's great. We have the formula, we have the state here for everything, but it's not balanced. There's 2 fluorines on the right. I see a 2 here, and I don't see a 2 here. So I'm going to fix that by putting a 2 in front of here. Okay? Now we have 2 fluorines and 2 fluorines. The other thing I notice here is that we have 2 chlorines. 2 chlorines here, but in the sodium chloride, we only have 1 chlorine. So I need to put a 2 in front of that, okay? I think I might have it. Let's double check everything. So 1 calcium, 1 calcium. 2 chlorines, 2 chlorines. 2 sodiums, 2 sodiums. That's good. And then 2 fluorines and 2 fluorines. So every atom is balanced. That gives me my final answer here. Okay. Once again, write correct formulas, correct states, and only change coefficients, or these white numbers here on the board. Don't change any of the subscripts, please, when you balance chemical equations. Thanks for watching, and please subscribe.